In the previous video I mentioned that exponential growth and decay occur in a lot of natural phenomena. So let's take one as an example. Let's say we've got a rabbit population and it increases at 15% per year, and we're going to ask how many years does it take for the population to double. So let's say we start off with the initial population R0. So that means that after 1 year the new population R1 is going to equal 1.15 times the original population R0. Now, just to be sure you're getting all of this, we'll just do this out in full. We start off with some original population, let's say it's value of 1, and then we're going to add on 15%, so it's going to be 15 upon 100, so we're adding on 15% of this 1. So let's take out the common factor. The common factor is 1, so we're left with 1 plus 0.15, so that's just 1.15. So the new population is going to be 1.15 times the old population, so it's simply an increase of 15%. So let's do that again. Now we'll do it for 2 years. So you can see here that after 2 years the population R2, which is the new population, will be the old population, which is now 1.15, and it's to the power of 2, so that's the squared times R0. So let's have a wee look and we'll see to make sure you know where we get the squared term from. So if we say that the population is 1.15 now, and it's now going to increase at 15%, so it's 15 upon 100 times the original population there now, 1.15. So we're adding 15% on to the new population, which is now 1.15. So if we take out the common factor of 1.15, we're going to be left with a value of 1 plus 15 upon 100 is 0.15. So that's going to give us 1.15 times 1.15, which is equal to 1.15 squared. So the new population is going to be 1.15 squared of the original population. Now we can continue doing that. So we could do it for 3 years, and after 3 years we would find the population would be 1.15 cubed. After 4 years it would be 1.15 to the power of 4, and so on and so forth. So in general we could say that after year n, the population Rn, so that's the population after n years, is going to equal 1.15 to the power of n times the original population R0. So if we look and see the format of this equation here, well, this is nothing other than our exponential growth function. So we have the value of a, which is a 1.15, and it's raised to a power, so the power here is an independent variable. In this case it's the number of years, but this could equally just be a value of x. So this little function here is nothing other than what was seen in the previous video, a to the power of x. So we can see here that this exponential growth and decay function occur naturally whenever we're looking at percentage increases, or for decay it would be percentage decreases. So we're still left with a problem here. How do we find out the number of years it takes for the population to double? Well, if we start off with the original population R0, then it's going to be doubled whenever we've got a value of 2R0. So we are interested in when 1.15 to the power of n times R0 is going to be greater than 2R0. Well, we should actually say greater than, in this case, or equal to. So we could cancel out the values of our R0 and we'd be left with 1.15 to the power of n is greater than or equal to 2. So the question now is, what is the value of n? Well, we could find the value for n by simply putting values in. We could put in 1, 2, 3, 4 and 5 and so on and so forth until we get a value here that is greater than or equal to 2. Now in this instance here, if you put the values into your calculator, you'll find that the answer to this is 5 years. So after 5 years the population will have doubled. But this is not a very mathematical way of finding it. We want to find some other way of solving this little equation. So what we really need to do is find an inverse function that will allow us to find this value of n. So that's what we're going to look at in the next video when we introduce the logarithmic functions. Those functions allow us to solve problems of this nature. So thank you for listening to this video. I'll get you in the next video. Goodbye.